Alright guys, for this video, we're going to go back converting between polar and rectangular coordinates, but now we're going to do the opposite. Now we'll actually move on to the following page where we'll be given the rectangular coordinates and we want to get the polar coordinates. Alright, so another way to look at this, if we have this right triangle, I could use Pythagorean's formula with the right triangle. Right, the hypotenuse is r. So a formula we could use, instead of saying a squared plus b squared equals c squared, we just replace those with x, y, and r. We could say x squared plus y squared equals r squared. So if I have x and y, I can just plug them in and I'll be able to get r. I'll be able to get that third side, the hypotenuse in the right triangle. Now the other thing we could use, if I wanted to get theta, right? If I wanted to solve for theta, and all I know is x and y, the best trig function to use is tangent, right? Because remember, tangent is opposite over adjacent. The y is the opposite. The adjacent is the adjacent is the x value. So if I did tangent of theta, it's always going to equal y over x, which is kind of what we did before in the unit circle. All right. So these are other two forms. This will enable us to go from a rectangular coordinate and get r and theta and make it a polar coordinate. So I'm going to use these to do actually the next page, and it's labeled 4, 5, and 6. So let's go to the next page. All right, so here's the next page. You can see now I have x and y. I want to get r and theta, which still gives me the same exact location. Okay, now the one thing it does say is let's find two corresponding polar coordinates pairs for the following rectangular coordinates. Now I'm going to put this in your directions. We'll always do this. Let's find an equivalent location on the polar system where r is positive and where r is negative. All right. Okay, so let's do these. All right. Okay. All right. So, and I like graphing these first. So if I graph, now this should be easier. Oops. If I graph that first one, negative 1, 1, I am in the second quadrant. Again, right? Negative 1, 1 is right here. All right. So I better get an angle that's in the second quadrant. It better be in between 90 and 180 degrees. All right, I'm going to go back to the last page. I have x and y. So remember, it's kind of like drawing this right triangle. Here's the right triangle. This is r. So it's going to be x squared plus y squared equals r squared. So I'm going to have negative 1 squared plus 1 squared equals the radius squared. So those both are going to give me 1. 1 plus 1 is 2. So r squared equals 2. Take the square root. So r is going to equal square root of 2, and it's going to be plus or minus. Right? Because remember, the radius, we could represent the radius as a positive or a negative, but it's going to depend on the angle. All right, now to get the angle, this is where we're going to go. We're going to use that tangent of theta equals y over x. Well, the y is the 1, and then the x is the negative 1. So this is just like saying tangent of theta equals negative 1. Now this is going to give us two answers. This is going to give us, let's see here, tangent is negative in the second and fourth quadrant. All right. So let's see here. And these are the pi over 4s. So in the second quadrant, it's 3 pi over 4. In the fourth quadrant, it's 7 pi over 4. All right. Notice how we have two angles, and I have two values for the radius, positive and negative. Okay, we're going to make sure we match these up. If this point is in the second quadrant, all right, if I keep the radius as a positive, what that means is I have to use the second quadrant angle, which is the 3 pi over 4. When I make that radius negative, then this point if you add 180 degrees to it, it's just going to move a straight line. It's going to be right here. It's going to be in the fourth quadrant. That's where we're going to use this. So the second point is going to be negative root 2, 7 pi over 4. All right. If I graph those, both of these are going to lie exactly right there. All right. Okay, let's do number 5. I'm going to, again, just kind of move this over. Now, the one thing about number 5, I kind of like this one right here, is it is an intercept. So the intercept ones are going to be quicker to do, and you're going to see why. All right, so if I graph this, I'm at negative 3, 0, which is right here. All right, now if you have an x or a y value that's 0, we're not really going to draw a right triangle for it. I kind of already know the angle. Look, the angle is 180 degrees right there. All right, okay, but it's negative 3, 0. So this is the x, this is the y. And then you can see we know what the radius is, the distance from the origin. I just moved 3. So r, we're going to say it's plus or minus 3. And then theta is, we could say 180 degrees. Or if I add 180 degrees to it, it's right here, which we could say is 0 or 360 degrees. I'll just use 0. You could use 360 as well. All right, now let's say that the radius is positive. If I make this radius positive, then I have to use this exact angle right here, which is the 180 degrees. Or you could say pi. Now, if I make the radius negative, this has to flip. I have to move it another 180 degrees. Again, I could go this way or I could go this way. I'm still going to end up here. And that angle here is at 0 degrees. All right, so these are the two possible points for number 5 right there. We could also say 3 pi and also negative 3, 0 radians. All right, so that's how, if you have x and y, this is how you convert and get r and theta, and you can get 2 points where r is positive and r is negative.